Electricity is a fundamental part of common life, powering everything from the lights in our homes to the devices in our hands. How does that electricity flow through the materials we use, like copper or aluminum wires? In this video, we'll explore how electrical conduction works in metals and why metals are such good conductors. Metals like copper, silver, or aluminum are excellent conductors of electricity. But what makes metals so special? The answer lies in the atomic structure. Metals have a structure where atoms are arranged in a regular pattern called a lattice. But unlike other materials, metals have electrons that are not tightly bound to individual atoms. These free electrons can move throughout the metal. This is key for understanding conduction. These free electrons behave like a sea of electrons, constantly moving through the metal. In the natural state, these electrons move randomly, but when we apply an electric field, like when we connect a metal wire to a battery, something interesting happens. When a voltage is applied across the metal, the electric field exerts a force on the electrons, causing them to move in a coordinated direction. This movement of electrons is what we call the electric current. Now, it's important to note that even when the electrons are moving in the direction of the electric field, they are not moving in a perfectly straight line. They still collide with the atoms, with the ions in the metal, which slows them down. So they're bouncing from ion to ion, going back, and then need to accelerate back again. This average motion is in the direction of the electric field is called the drift velocity, and it's actually much lower than you might think. Even though the electric field propagates at nearly the speed of light, individual electrons move relatively slowly, colliding with atoms as they go. And I'm talking about millimeters per second. Let's connect this idea to one of the most fundamental laws of electrical circuits, Ohm's law. Ohm's law tells us that the voltage across the conductor is equal to the current flowing through it multiplied by its resistance, as we saw in a previous lesson. In metals, resistance arises due to those collisions between electrons and atoms and that we just discussed. The more these electrons collide, the harder it is for them to flow, and the higher the resistance is going to be. The resistance of a metal wire depends on its material, its length, and cross-sectional area. This is expressed by the formula R is equals to rho L over A, where rho is the material's resistivity, L is the length, and A is the cross-sectional area. One key factor that affects a metal's ability to conduct electricity is temperature. As metals heat up, the atoms in the lattice vibrate more intensely. This increased vibration causes more collisions between electrons and atoms, increasing the resistivity of the metal. This is why wires and circuits heat up as more current flows through them. It is a direct result of increased resistance. Because the ions vibrate more, they occupy a wider cross-section, offering more opposition to the electrons. Let's briefly compare metals to insulators, like rubber or glass. In insulators, electrons are tightly bound to their atoms and can't move freely. This means that they can't carry an electric current, making insulators perfect for coating wires to prevent electrical shock. Metals, on the other hand, have those free electrons that are ready to move when an electric field is applied, making them excellent conductors. Because of the ability to easily conduct electricity, metals are used to countless applications. Copper is the most commonly used metal for electrical wiring in homes and industries. Aluminum is used in high-voltage power lines due to its lightweight and cost-effectiveness, even though it's a slightly poorer conductor than copper. Silver is a very good conductor as well, but its price makes it not suitable for many applications. Metals are also essential in modern electronics, from the circuit boards in computers to electrical systems in electric vehicles. To summarize, metals are excellent conductors of electricity due to the free electrons which move through the material when a voltage is applied. However, resistance is caused by collisions between these electrons and the atoms in the metal, which increases with temperature. Understanding these properties is crucial in everything from designing electrical circuits to building the technologies that power our world. Thanks for watching, and may science be with you.